Hello, and welcome to this Infilink video tutorial. In this two-part video series, we are going to understand all about Infilink tags. In part 1 we will see basics of tags and tag groups, creation and naming rules, using dead bands, value limits, and linear scaling, finding and use tags in a project, data logging and retentive settings. In part 2 we will see how to use virtual tags, importing and exporting tags to CSV file, finding and replacing tags, tag.fields, OPC tags runtime working, data change scripts for tags. So let us get started. Infilink has 4 basic tag types. Memory tags. Memory tags are like local variables inside Infilink project. You can create and use as many memory tags as you want in your Infilink project. OPC tags. OPC tags are data entities those access data from external OPC server. The most used OPC server with Infilink is KEP Server X. You can use any other OPC server supporting OPC DA protocol with Infilink. OPC server will communicate with external devices like PLCs and read data from them or write data to them. Infilink requests data from OPC server at project start. OPC server sends initial data for all OPC tags to Infilink in the beginning. After that, data is sent by OPC server to Infilink only on data change. Tag data is read from external devices by OPC server at specific scan rate. The scan rate can be set by the user. Your Infilink license type will determine the total number of OPC tags that can be used in an Infilink project. DDE tags. DDE tags also access external data just like OPC tags, but use external DDE data server. DDE is older data transfer protocol and is mostly outdated. Infilink supports it. Some small devices still use DDE protocol and custom DDE servers. It is relatively easy to write DDE servers, and small device manufacturers will prefer DDE protocol because of their simplicity. Operation of DDE tags inside Infilink is identical to OPC tags. Virtual tags. Virtual tags are not actual tags, but are almost like pointer to memory, OPC, or DDE tags. There is no limit on the number of virtual tags you can use in an Infilink project. We will check out their usage later in this video. There are 2 more additional tag types in Infilink. System tags. System tags are just like memory tags, but those are created by default when you create Infilink project. Currently there are 22 system tags. These tags are managed by Infilink and provide important data to project. Data like system time and date, users logged in status and level, system-wide active alarm count, and so on. In future there may be more system tags added as the product grows. Driver tags. Currently Infilink has one built-in device driver, supporting Modbus TCP/IP protocol. So if your project is going to use devices using only Modbus TCP/IP protocol, then you need not buy any OPC or DDE servers. This driver uses proprietary communication protocol, which is different from OPC or DDE protocol. Use of this built-in driver is completely optional. Infilink may provide more of these kind of custom drivers in future. Tag groups. Memory tag groups. Memory tags can be grouped together. Memory tag group will contain only memory tags. There is no limit on the number of memory tag groups which you can create in an Infilink project. Typically, memory tags related to one equipment or one section of process will be grouped together. OPC tag groups. You can use one or many OPC tag groups in an Infilink project. Each OPC tag group will be associated with one OPC server. OPC tag group will only contain OPC tags. DDE tag groups. You can use one or many DDE tag groups in an Infilink project. Each DDE tag group will be associated with one DDE server. DDE tag group will only contain DDE tags. Virtual tag groups. Virtual tag groups contain only virtual tags. You can have many virtual tags and tag groups in your project. There is no limit. More about tag and tag group names. Maximum limit on number of characters in a tag group or tag name is 32. Tag or tag group name must start with a letter. Space and any other special characters are not accepted for a tag or tag group name. Infilink will automatically prohibit entering of any non-acceptable character for a tag or tag group name. Tag group names must be unique in an Infilink project. Tag name has to be unique in a tag group. Tag with same name can exist in more than one tag group. Tag group and tag names are not case sensitive. For example, tag 1 and tag 1 will be treated as same tag name. Now let us start Infilink design mode and actually create few tag groups and tags. Let us create a new Infilink project. Now let us see how tag groups and tags are created. We see that Infilink has automatically created system tag group and created 22 default system tags into it. You can go through this list. Let us now create memory tag group. Tag group names are of maximum 32 characters and must start with a letter. Infilink will automatically restrict you to enter only acceptable characters. Tag group names must be unique. Select the tag group name in the list on the left and click Create New Tag button. This is a tag creation dialog box. All the attributes of the tag are set here. You can also define alarms for this tag in this dialog box. Here are the possible data types for a tag. Characteristics of the data type like signed or unsigned, maximum values that can be stored into it, are described in Infilink help documentation. You will enter DDE server name and topic name here. This information can be found in DDE server documentation. Advanced DDE and CF text are two different communication formats of DDE protocol. Advanced DDE is the faster one. Consult your DDE server documentation to see which format it supports. These are some advanced options for the DDE tag group. If you select initially disabled at a run mode start, then you will have to enable this tag group using menu item or script command. Using script command, run, you can start the execution of your DDE server exe file. In that way, DDE server will automatically start after you start Infilink run mode. If you are doing this, then initially disabled option is useful. Let us now create a DDE tag. Server item is the item name of the data entity in DDE server that you want to access. You will find information about server item name in server documentation. Infilink tag data of any tag can be accessed by any external application, like Microsoft Excel, using DDE protocol. In that situation, Infilink will act as a DDE server. This DDE client access attribute decides whether you want to allow such access to any external DDE client application. This internal, read-write, or read-only attribute controls whether data of this tag can be changed from within Infilink using scripts or input animations. Let us now create an OPC tag group and tag. Program ID is the ID of the OPC server. When you install any OPC server on your computer, an entry of this program ID is created into System Registry. By clicking the button next to this field, Infilink finds the program IDs of all the OPC servers installed on this computer. You just select the program ID of the desired OPC server from the list. I am going to select Kepware, KEP Server EX, OPC server from this list. If you wish to use OPC server running on a different computer on the network, then you will select this remote option and provide machine name and program ID of the OPC server on that remote computer. You can specify update rate in milliseconds. Infilink will use this value to request OPC server to update the tags for this OPC group. Default value is 100 milliseconds. But you should change it if it is okay to use slower update rate. Doing that will reduce the processing power demand on the system. Here are some advanced options for this OPC tag group. Now, let us create an OPC tag. first field on this dialog is the server item name for this OPC tag. This will come from OPC server. You can click the button next to this field. Infilink will automatically start the OPC server for this OPC tag group. The OPC server is expected to load the last used OPC server project on startup. After OPC server is started, Infilink will query the OPC server for available OPC server items and populate a dialog box with them. You can select desired server item from the list. These are the group names and item names available in the OPC server. You can use the filter fields to narrow down your selection. Double-click the desired OPC item name from the right list box. Infilink has filled the server item field. It has also automatically suggested tag name that will be used in Infilink. This tag name will be used inside Infilink for scripts, animations, and so on. You can keep the suggested tag name or change it. But don't change the server item name. Notice that you will see two different data types. Engineering type is the data type that Infilink will use internally. Raw data type is the data type coming from OPC server. It is a good idea to keep raw data type as default. While getting the data, Infilink will automatically do necessary conversion. Proper data conversion will also be performed when writing data from Infilink to OPC server. Internal security attribute of read-only or read-write will determine whether Infilink scripts and input animations can change the tag data. DDE client access attribute will determine whether and how external DDE clients will be allowed to access data of this tag. Note that Infilink will be acting as a DDE server in this case. You will have to enable the DDE server feature for the project. It can be done on Project Properties dialog. Now, let us create a virtual tag group and a virtual tag. Notice that most of the fields are grayed. Other usual tabs like scripts and alarms are also absent. This is because virtual tags are not real tags. These are just placeholders or pointers. In runtime, you can make them refer to another real tag by using script command shown here. We have just created tag groups and tags of 4 different types which are used in Infilink. These created tag groups and tags are also visible in the Project Explorer. This is handy when you are developing other project features and want quick access to the tag names. Data coming into Infilink from OPC server can be automatically processed and made suitable for using it in Infilink. Infilink allows you to set deadband, value limits or clamps, and value scaling for incoming tag values. In this section of the video, we will understand about why you should use deadbands. Using value limits or clamps on incoming tag value. Using linear scaling on incoming tag value. Many times the process variable like temperature might be normally changing by fraction of degrees, and that change can be treated as insignificant. You might be interested in seeing the change, which is more than couple of degrees. In this situation, you can tell Infilink to ignore changes less than 2 degrees by setting a deadband of 2 on incoming tag value. Doing this also improves the overall performance of your HMI or SCADA project, as Infilink only works on tag value changes more than 2 degrees. Sometimes, you may want to ignore incoming process values which are below or above certain limits. You can do this by setting upper and lower value limits, or clamps, on incoming value. Take this example, there is a current sensor, giving out values between 0 to 20 milliamps. This current value may be representing process temperature value, between 0 to 100 degrees. You can use linear scaling feature of Infilink for this purpose. We will now actually see how these three features are set and used for a tag in Infilink. We will start by creating a blank Infilink project. There is an OPC server running in the background using its simulator device. We will use a tag from that simulator device. That tag will represent value of current from 0 to 20 milliamp sensor. We will simulate the current value change by using a slider object. Sliding that slider will change the value of the tag in the simulator. We can see that by using the slider object, we are changing the value of tag current from 0 to 20. This value is getting written into OPC server as we slide the slider. We will see the value change happening in OPC Quick Client, which is connected to OPC server. We will now create OPC tag named temperature. We will use the same data value representing current from the OPC server. We will use Infilink feature of linear scaling and convert that 0 to 20 mA value to 0 to 100 degree temperature value. We see that current sensor value changing between 0 to 20 is now getting converted temperature value changing from 0 to 100 degrees. We will now use deadband property to ignore the current value changes, which are less than 2 degrees. To see the effect, we will create one more tag, current with deadband. Then we can observe the values of both the tags, current and current with deadband. Creating one more tag to show the working of value clamps. Using same data value from OPC server representing current. Typically, Infilink projects start as small projects and everything is easily manageable. Slowly project size grows, many tags and objects are added or deleted. Different programmers work on the project. After some time it becomes difficult to really know which tags are actually used in the project. Infilink helps by analyzing your project every time you save the project. At every project save operation, Infilink compiles entire project, determines its integrity, and at the same time marks out used and unused tags. To see the unused tags, just save the project. Open up a Tag Groups and Tags dialog. You will see that the tags which are used in the project are displayed with yellow background. You can then safely delete unused tags. Let us see that with actual Infilink project. We see that these 4 tags are displayed with yellow background, that means they are used in the project. Let us delete couple of tag value displays and make those tags unused and check this dialog again. I will delete these 2 value display objects, displaying values of tags, current with clamps and current with deadband. Saving the project which automatically causes project compile operation. Then I will check out that Tag Groups and Tags dialog again. We see that 2 of the tags are not having yellow background. That means those are not used in the project and we can safely delete those tags. While defining a tag, you can also set various data log attributes. There are 3 different alternatives for data logging of a tag. You can use them selectively as needed. You will have to enable and set up Data Logger on Project Properties dialog. At project start and runtime, value of memory tag is as set in initial value field. But sometimes users want to initialize the memory tag value at project start with a value which was present at last project close. This can be done by checking the retentive checkbox. Some users reported a problem of power failure. At power failure, last tag value at project close cannot be saved. If you face such problem, then you can use retentive to checkbox. Infilink will periodically save the tag values if retentive to checkbox is checked. The time interval for this periodic save operation is set on Data Logger tab of Project Properties. You can click the button Retentive More Information for getting more information. You can use only one retentive option or both the options together. We have finished part 1 of this video. Please do check out part 2 of this video. Thank you for watching this video and bye for now.